Today I am discussing about differential coefficient of y equal to fx and differential of y and x. Y is a function of x, y equal to fx. Let delta x be the small increment in x and delta y be the corresponding small increment in y. Then equation 1 becomes y plus delta y equal to fx plus delta x, or delta y equal to fx plus delta x minus y, delta y equal to fx plus delta x minus fx, dividing both sides by delta x and taking limit delta x tends to 0, we get delta y by delta x, limit delta x tends to 0, fx plus delta x minus fx by delta x, limit delta x tends to 0, or dy by dx equal to limit delta x tends to 0, fx plus delta x minus fx by delta x. Here left hand side dy by dx differential coefficient of y with respect to x. Here dy by dx is called differential coefficient of y with respect to x. This value is equal to right hand side limiting value. Now differential of y is written as dy, and differential of x is written as dx. Dy divided by dx or dy by dx is same as differential dy by dx in limiting position. Then dy and dx are called the differential of y and x respectively. Now geometrically, what is the meaning of dy by dx at a point? Suppose y equal to fx is a curve, continuous curve, taking x and y as a axis, pxy is any point, and if delta x and delta y is a small increment in x and y, suppose that delta x is positive, then q becomes coordinate x plus delta x, y plus delta y. Draw perpendicular PM and QN on x-axis. PR is perpendicular on QN. Now join PQ. PQ is called a arc of the curve. When point Q comes near to P, suppose first point is Q1, Q2 is very near to P, Q2, Q3, then PQ1, PQ2, PQ3 chord becomes smaller and smaller, and finally chord becomes the tangent at P, and this tangent makes angle with x-axis in positive direction, suppose psi. Now QR by PR equal to tan QPR and Q1R by Q1R1 by PR1. This is equal to tan Q1 PR1. In this way, finally we get, suppose finally NR by PR equal to tan NPR, and this is called dy by dx at the point P. And from the triangle NPR, there are many perpendicular and base we get. If it is dy, then this quantity is dx. If this is dy, then this quantity is dx, and smaller and smaller. If this one is dy and this one is dx, that is the same value of tan of this angle. So in differential coefficient, we get a limiting value, that means tan NPR, and differential, there are many values which is dy and dx are different but getting the same value. So dy by dx and differential coefficients are finally they become divisible. As in the case of geometrically, we get dy by dx as a rate measure, dy by dx as a increasing decreasing curve, dy by dx we get the maximum or minimum value at a point where the curve is concave or convex towards. And also in integration we use fx into dx, where dx is the differential of x. There are many use of differential in calculus, also area, rectification, volume. We get use of dy by dx or dy and dx. In any modern area, modern technology, where we use the rate measure, we use the differential coefficient or derivatives, and any type of, if the function is known, then we get the area, rectification, volume, we use the differential and rate measure, and many other aspects we use in differential and integration.